Good morning. I'm recording this on a lovely Sunday morning. Well, not morning anymore. It's 12:30. I hope that you have the chance to take some time today and do something that's fun outside. I hear rain comes again tomorrow. So if you see me drift over this way, I'm looking at that gorgeous blue sky and I'm thinking about working on my garden in a little bit. But enough about me. Let's talk about you. Today, it's time for you to do PhET Part 2. Most people were pretty successful with PhET Part 1. I would suggest that if you are one of those people who never got a stylist, that you contact Mrs. Volk and see if she can get you one, because it sure makes all the drawing on the documents way, way easier. All right, so what you're going to be doing today is going back to PhET and you're going to be working on the simulation and recording a few answers for me. So I've already opened up a couple things on here. I have my simulation ready to go. Last time I asked you to play with these things so you knew what was different about using manual versus oscillate versus pulse. I asked you to play with these so that you could tell what happened when you changed the ending over here. We talked about damping and about tension. Today, you're actually going to make measurements on here, okay? When you do this, there are a couple ways to make things easier, and I'll show you as we go through the assignment so that you can get a good feel for how you can get good information on this and not have to spend forever on it. All right, so on your assignment, I have to keep playing with it because I have different labels on here in different places. Here's your assignment. When you start, it's going to say, set it up like you did in part 1. And what I mean by that is all this stuff. We're going to do oscillate, no end. Here's an amplitude of 0.5, a frequency of 1.5, no damping, high tension, rulers and timers. So I'm going to take a second and do that. I'm going to do oscillate. Oh, by the way, when you were doing the part 1 of this, then I hope that you noticed that if you had, here's no damping, if you had this, the wave changed a little bit over time. You see that? Now it looks a little different, almost gone. Now it's back, bigger, and it just goes a little crazy after a while. And that has to do with that word reflection, because when that wave hits over here, it gets bounced back, and so the wave gets changed over time. Some of you guys misinterpreted that word wave reflection for me, and you gave me really quite a lovely reflection on the activity. Nah, not what we're talking about. We're talking about vocab. Okay, so we're going to do oscillate. We're going to do no end, no damping, and already I talked too much and I've forgotten. Amplitude 0.5, frequency 1.5 is how I'll set that baby up. Amplitude 0.5, and if you get close, remember you can do that. Frequency 1.5. Okay, we got our wave set. Now, almost immediately, we're going to change it. So it says, okay, you've got all that. Awesome. Here are the investigations. So we're going to look and see how one thing affects another thing, like it was a lab. So make sure your preset values for everything except amplitude, which you will change as you collect data. I'll fix that sentence because that's a sentence fragment. Make sure the preset values for everything match what's above, is what that should be. Everything else should be set as described above. I'll fix all that wording. Set your amplitude first to 0.25. And so you're going to do that. And you're going to actually draw in here where it says amplitude 0.25, draw what one complete wave looks like. Then you're going to leave everything else the same, but change amplitude to 0.5, draw it here. And then amplitude 1.0. And draw it here, okay? Define amplitude comes next, and based on the last assignment, I think you can already do that. So what you're going to do is go here, and we're going to change this amplitude to 0.25 for the first one. Now, you have to let it run for just a minute to get it so it's just that wave, and I find it way easier to change it to slow-mo, okay? Now, how do you know when it's one wave? Well, the little green balls here, I use those only to be up and down. And so this one just started down. I let it go a little too far, so I can let it go. And when it's about to be the top, I can step it up. I think that's about the top, okay? So what it wants me to do is sketch one wave when it is 0.25. You can do this a lot of ways, but here's one way. I move my ruler down. I can move this ruler up too, and I like to do that just because if I put the 0 here on that equilibrium, that rest, then it tells me how high this wave is. This wave, 0.2, 0.4, 0.6, 0.81. So this is around 0.2 centimeters high. The wave itself goes from crest through trough up to the next crest. So the wave is this long. So I said you could do it a couple ways. This is one way. I'm going to have you do it later, so I thought I'd just show you now. You measure from crest of one wave to crest of the next. Okay, totally easy to do. You can also, though, get the same exact answer by having the wave start at rest. So here it is at 0, up, down, back to 0 again, ready to start the new wave. Either way works. You should get the same answer both ways. I get like 4 point almost 2 here. If I did it the other way, I get from here to here, 4 point almost 2. Okay, so it works the same. All right. So I just let that run, and this one says, now draw me one complete wave for each situation. So I am going to draw like this is the beginning and this is the ending. And I am going to draw, how high did that wave go? Do you remember? About 0.25, right? Because that's what our amplitude is. So about 0.25 up, and it went about 0.25 down too. So right here, I would draw one wave where I had it, if I have it look like this one. Okay, I'm going to start with a crest, and I don't have my stylus with me, so I would start here. There's 0.25 crest. I'm going to go through 0. I'm going to do trough. I'm going to go through 0. And I'm going to be up at crest at 0.25 again. Okay, that's how it would look. From 0.25 through 0, down to 0.25, up to 0, up to 0.25. So now I go to the next one, and I'm going to change the amplitude. And if I change the amplitude to 0.5, I let it run a second, get that wave in there. Okay, and now I'll go to slow-mo. And I know I should be able to move this ruler. Oh, I kind of messed something up, didn't I? Maybe. No, I'm good. Okay, there we go. Sorry, I'm slow, but I'm all fussy about it. Oops, I went too long. So I want to get my crest up there at 0.5. Okay, so now, same thing. I want to draw a wave. How far does it go? It starts at 0, goes down, up to the next crest, right around 4.1-ish, right? So I'd go back to my assignment, and here, I'm going to start with my crest at 0.5. I'm going to come down through 0, down to 0.5 below, back up to 0, and back up to 0.5. So same shape, and I can fit one wave in that same area, okay? And then the next one, I'm going to change this to 1.0. So I'm going to let it run a second. Get that wave in here. There we go. I'm going to end up with slow-mo. I'm going to move this because this should be right up. It should be at an amplitude of 1, right? So I'm going to start it. And when I have my crest up there, oh, that good? Okay. So my wavelength, crest, through 0, trough, through 0, up here, oh, right around 4.2 again. So I'm going to go here. I'm going to start my crest at 1, go through 0, down to 1, up to 0, and back up. Okay, one wave at each of those. So down here, you can define amplitude already. And then here's this question: does amplitude affect the wavelength? When you change the amplitude, did it change how long the wave was? So when you go back, I have the amplitude of 1 centimeter on there right now. Let's just take a look. When I do that, how long is the wavelength? I measure with the ruler. One complete wave goes to 4.2. If I change it back to 0.5, I'm going to move this down. There's 0.5, right? So if I do this, look at that. Crest, trough, crest, oh, about 4.2. I change it again to 0.25. I might have to stop in a minute and talk to my dog, so hang on, okay? I let this run. I'm gonna move this down so I can clearly see there's 0.2, there's whoops. Okay. Oh, you can measure that. So I'm going to let you measure those, but actually when it says wavelength, that's length. Use the ruler and measure from the first crest to the next crest, okay? And so I put it here, actually you measure the wavelength using the ruler. Now, as amplitude doubles, so it went from 0.25 to 0.5, what happened to wavelength? As it went from 0.5 to 1.0, what happened to the wavelength? Write it down. Oh, and dang it, I cleaned up this whole paper. I'm going to put this graph back in. I meant to have a little graph right here for you. What did you change? Amplitude. Label the x-axis amplitude, y-axis wavelength, and sketch me the pattern. Is it, if I doubled the amplitude, did I double the wavelength? That would be linear. If I doubled the amplitude, did I quadruple the wavelength? That would be quadratic. If I doubled the amplitude and cut the wavelength in half, inverse. If I doubled the amplitude and nothing happened to the wavelength, horizontal. So I'll put a graph over here, and then I want you to label this. Next question. Hang on. Sorry. Okay, I'm going to pause my. Sorry. Okay, back to what we were doing. So on this page, you can define frequency, I think, already. But down here, it says, okay, what do waves with different frequencies look like? And so it asks you to set your tension to high and keep your amplitude the same. When you do that, you it doesn't matter what your amplitude is, just make it big enough you could actually see it. And so it has, you set your frequency to 1 and then frequency set to 2. So here's how we're going to do that. On this page, sorry, I have a misbehaving puppy. I'm going to make my amplitude a little bit higher so that I can just see it. So you don't have to, but I'm going to make mine be 0.5. And it says make your frequency be 1 and then 2. And so I'm going to leave damping at none, tension at high. I'm going to let it run. Okay, there we go. Okay, so I've got my wave. And if my amplitude is at 0.5, I'm just going to move this up. Okay, all right. So the question is, what do waves of different frequencies look like? So you just saw the frequency of 1 hertz, but if you're going to sketch it, then you want to be able to give me some sort of detail. So let's look and see, why don't we look and see in that simulation, how many complete waves are on the screen? How could you draw this? And so when I look at this one, I've got crest, trough, crest. And then by the time it goes through this window, it's off our ruler. So what I would do is on here, I would make this be that ruler. It goes up to 6.2 centimeters. And I would draw at 0 is a crest, at right around 3.1 is a trough, and at 6.2 is my next crest. So then if I take my frequency now and I make it 2 hertz, that's going to change it. So over here, I know. I'm going to let it run. Oh, that's really different, isn't it? So I'm going to make it slow-mo so I can put the crest at the top again. I just missed it, but good enough. So I have a crest at 0. I have a trough, like at 1.6. Moose, wait, just wait. I have a crest at 3.2. I have a trough here, like at 4.8. And I have another crest at 6.2. So here's what the big takeaway is. When I change it to a frequency of 2, I have 2 waves. Here's 1, 2. When it was a frequency of 1, I had 1 wave. Okay, so that's what you want to draw in here, define frequency. Now, wave velocity is kind of a tough one. I think what I'm going to do, because I need to concentrate when I talk, I'm going to put Maisie and Moose outside, okay? Just a second, I'm going to leave it running because otherwise it's kind of a pain to stop recording and go back. So a lot of people think wave velocity is like frequency, because frequency is like frequently, how often, right? Well, wave velocity is like any other velocity. It's distance over time. So how far does a wave go over a certain amount of time? And so this is step by step how to do it. Number 4 is all about just, can you do it? Okay, so set up the crest, first crest at 0. And you can look and match these measurements down below. Start the timer and let the wave move in slow motion. Watch the crest move from the 0 mark all the way to 5 centimeters. Stop the wave when the crest has reached the 5 centimeter mark, and you'll record the time, okay? So here's how that looks. Back to this, always slow-mo. and I have the timer setting right here. And so what I'm going to do is watch this crest not vibrate up and down. That's not what we're talking about. We're talking about watching this crest move all the way over here to 5, okay? To do that, slow-mo, I am gonna start the clock when I press go. There it goes. There's that first crest. It's at 4. Oh, it's right around 5. If I think it needs to go slightly further, I can use that. Okay, so I'm going to say 0.8 seconds. Okay, so let's look at it one more time. I'm going to clear the timer. I'm going to have this wave go back to 0. Okay, so I'm going to look at this. I'm going to start my timer. I'm going to hit this button, and I'm watching this crest move across to 5. And I can pause when I get close and inch it up so I get the right measure. And again, I get around 0.8. Okay, so what you're looking at is the distance it travels over a certain amount of time. So here, even though I just did that for you, do it, practice it yourself. So distance, the crest went 5 centimeters. The time it took, 80 seconds, 0.8 seconds. 5 divided by 0.8, 62.5. So its wave velocity is 62.5 centimeters per second. So at number 5, the question is, so does amplitude affect wave velocity? Tell me, either yes or no. So what you're going to do is what I just did. Measure the time for the crest to move from 0 to 5 centimeters. Take that 5, divide it by the time to calculate your wave velocity. Okay? So do it with this amplitude, and you're going to have a certain time that you get. Write that time in this blue box, and then do 5 divided by time. There's your speed. Do it for an amplitude of 0.5. Here's where I write the time it took to go 5 centimeters, and then I do 5 divided by time. And here's 1 for amplitude. I write how long it took it to go 5 centimeters, 5 divided by that time. Then you'll be able to tell me, as amplitude doubles, wave velocity doubles, quadruples, is cut in half, or stays the same, and what is that relationship? You're going to put the thing you changed, amplitude, and the thing you measured, wave speed, and draw me what that graph looks like, okay? The last one on here, I believe, is tension. And so for tension, that's the other thing at the bottom of the screen. You're going to set the frequency to 1 hertz. You're going to change tension. So as you change tension, is the wave speed affected? Yes or no? Wave speed is still distance divided by time. So low tension, here's where you'll put the time it took. Medium, the time it took. High tension, the time it took. And you can calculate then 5 divided by the time here. 5 divided by the time here. Okay? Then you can answer this correctly. So here you're guessing. Here you're telling me what really happens. Wave velocity is determined by the material the wave is traveling to on this one. Think about what you just did, your experiences, and what's different about these drawings of the molecules in those substances, and see if you can answer this question. If you cannot, then research it. This part is a little tricky with what we've just done, and so I want to come back and talk about that with you perhaps next time. Do your best on it, and I think you can probably get at least 2 of those correct, but the third is tricky. And then at the bottom, on this one, I want you to actually identify the parts, use your stylus, and then here, measure the wavelength with the ruler, measure the amplitude with the ruler. tell me the velocity, because you here could do distance. Can you do time? How do you do that? On here, I don't think you can actually do it for this one. Do it for your own. And tell me, this is the important part. How do you measure the velocity? All right, so I'm going to go back in. I'm going to fix a couple bits of wording, and I'm going to put a graph in that was missing. And other than that, I think we're good. So here's what I'm expecting. If you start doing this and you get confused, which is really easy on this, pause the assignment, go back and look at the tape again, this awesome video that I've done for you. If it's still hard, hey, email, okay? Ask questions. I'm happy to help. Your teacher's happy to help if I'm not your teacher. All right, have a great rest of your day Sunday.